Now, a couple of things about Mach3. Mach3 has been around since about just before 2000. So it's well established and it works very, very well. There is a new program out called Mach4, but you can only use that on one computer. Although it will work on that particular one will work on a Windows 10. And I will, later this year, be moving, having one of my machines operating on Mach4 as well. But this is the cheaper brother then, and well established, and it works very well. So it may look complex, but it's really not. When you get a bit of a handle on it, it's really, really easy to use. Now, this red reset button flashing here, nothing. You know, you can press the... Incidentally, what I was doing there was using the number pad, and like the 8 and the 2, that's y-axis back and forward. The 4 and the 6, that's the x-axis that runs left to right, and the 9 and the 3, or up and down, page up and down, that will raise the head, the z-axis up and down. It won't do anything at all until that stops flashing. So to get that to stop flashing, we press reset. So now it's live. Mach3 now is talking to the machine, as it were. So if you press a button, see, it's going back, forward, side, side, up. We want to go up a little bit because we want to put a tool in. Okay. So that's how to manually move the machine, and that technically is called jogging. Alright? I don't know why they call it jogging, but that is the word for that process of moving the machine around. Okay? Called jogging. So, having showed you how to jog, I'm going to show you how to change gear, how to change speed. Now, in Mach3 has a sort of an electronic or computer generated one of these. This is an MPG. I don't know if you can just about see it up there. This is what they call a MPG is a manual pulse generator. You turn this wheel and it'll move this. Okay, and you've got a selector knob on it as well, and also a digital readout that tells you. I'll fetch you down here and show you. It's got a digital readout on it as well. You don't have to have one of these. There is one built into Mach3. Now to get at it, what you do is you press the tab key on your keyboard, and there it is. Okay. Now to change speed of the jog setting, alright, you come here to this little window here. Now you can either press these little arrows, see it going up in a percentage term. It's 40%. Now if you remember how quickly it moved before, alright, here's the Z. Oh, sorry. So here's the X. Much faster, isn't it? Okay, so that's how to change that. But I would suggest you run quite slowly until you get used to it, because you could bash up against something or snap a tool off. Very easy. I've done it quite a few times. Okay. So we'll come back down to 10%. There we are, 10% jog. It's set there now, 10%, nice and slow and easy, because we're going to set now the start of that job. Okay, the work offset, or the G54, or the 00 of the work. That's just another technical name for it, the 00, or just the 0. Okay, so I'm going to put a tool in. I'm going to put this nice sharp tool in, and but first of all, I want to show you how to get rid of that. Now is just press the tab key again. Actually, what I'm going to do, so what I'm going to do is I'm going to load in the file first. So I brought you in a little closer now to the MAX3 screen, and I'm going to show you how to load a G-code. And I'll actually show you what a G-code is in Mach3. So you come here to where it says File, open that, Load G-code, and it's found the file. There's our file there, and come over, hover over it and double click, and there it is in. And this is actually G-code. You really do not have to understand it, but if you're interested, just to cut that hole, this is the G-code to cut that hole. It's all coordinates. Many lines of code all the way down to the bottom where it ends. So all the way back up the top again. So that is the amount of G-code required just to cut that hole out. So now we're going to tell Mach3 exactly where the start of that job is, or where the middle of that material is. Okay, so there's the end of our tool. It's a very sharp tool, and there's our cross in the material, and that's where I want to start this job, in the middle of the material. So I'm just going to jog it around until I get this point in line with that cross there. So just use the keypad to do that. Down a bit. Just a little bit. You notice I just scratched it there because I was too far down. That looks pretty on the mark for me. So I'm going to show you, what I'm going to do now is I'm going to zero the X and Y. We're going to swap this tool out and put a different tool in. But for the X and Y, we need to zero this now, and I'll show you how to do that. Okay, this incidentally is the DROs, or digital readouts. This is the X, Y and Z, and that's for the fourth axis, which is not fitted to this machine. So we are going to tell Mach3 the 0 position of the X and Y, which is simply you just come over to the X button here and go X 0, Y 0. So we've just zeroed the X and Y. So now I'm just going to swap the tool out, put this one in, and we'll find the end of this tool in relation to the material. So the simplest method to find the end of that tool in relation to the material is just get a piece of ordinary paper. This is a piece of A4 that I've just taken taking off the end. And bring it down slowly and just move the paper. I'm actually using the, there, it's just grabbed it there. So now I can safely say that tool is just scraping or just on the top of that material. So we can set the 0 in the Z. So now we come here to the Z and press 0. So now we have set the 0.4 that piece of work. Now it is always a good practice to come over here to the regen area, press that, and what Mach3 does, it runs through the code and checks itself out to see exactly where it is, and you can see that the crosshairs here is actually in the center of our piece of work, which is just represented on this graph here. So now I'm going to lift up the tool, and you can see the DROs operating here. That's telling me I'm 12, 30, 40, 15 millimeter above the material, nearly 16 millimeter. And if I show you down there, you can see that it is so. So I'm now going to make sure all the doors are shut, because this is going to spray coolant around a little bit. And we will set this cutting, and I'll give you the best view I can. Incidentally, all I'm going to do is put the cursor over here and press cycle start, and off it'll go. So what I'm going to do is turn my coolant on and make sure that it is going to be pointed roughly at the end of that tool, because as it's spinning it's going to cool it. Oh, get on there, there you go. It's going to cool it and also wash away the swarf, so it's not going to gum up the end of the tool. That's about perfect there, so we'll start it up and shut this. And there is a perfectly cut out circle, clean, perfect circle. A bit damp, but it's just left a little tiny tag there. But as you can see, perfect. So we'll just check the dimensions of that. You read that? It is perfectly 55 millimeters, you know, plus or minus a thousandth of an inch. Perfect. Okay, so having machined this out, and I've showed you how to make the tool paths in Carveco, in this case Carveco Maker Plus. What a simple affair it is to make the paths to cut a circle in brass. Now, you will notice on my home page that I think about 4 videos back I did a full, nearly an hour I think, video in Carveco Maker Plus of how to make the design that I'm going to carve into this, a 3D relief into this medallion. And it is exactly how a jeweler would do it, to make a stamp or a coin. How the mint would do it is exactly how it occurs, and how make the tool paths in that. This is going to be mounted in a piece of wood, then it's going to be set in here. Alright, the piece of wood's going to be set on here, and this is a very robust CNC router, 400 by 400 by 125. That's the work envelope, and I designed and made this. And again, all the plans and the parts listing and where I bought them and how much I paid, including that what's called an offline controller, so you don't need a computer, that does it all. That is a computer in that, and it operates exactly the same as Mach 3 or Mach 4, and as it works out, about half the price. So all plans, all parts, and the pricing to make this simply made with I just used a drop saw, and I used a cordless drill and a very simple drill press. Okay, very cheap, very simple drill press. You can normally pick up for about $100, and you can make this for yourself. This whole build was less than $1,000, including the 800-watt spindle motor and power supply for it. Everything. All that information and the plans are available to you on my Patron pages. So, until the next video, thank you for joining me. Please press like and subscribe, and if you would like to become a patron to this channel, because it is the patrons behind this channel that actually allow me to do things like this and bring them to you and teach you how to use them. So thank you for joining me in this. Bye for now.